everyone, my name is Nikhil and today I'll be talking on the topic Ocean Deposits and Bottom Fauna. This is chapter 2 from a textbook of oceanography by James Travis Jenkins. Introduction. Have you ever wondered what is the ocean made of? Or what lurks beneath the deep dark depths of the ocean? Well, in today's video, we'll be focusing on these key concepts of oceanography, mainly marine deposits and deep sea animals. Classification of marine deposits. Marine deposits can be classified based on 1. Whether they are littoral, shallow water or deep sea deposits, or 2. Whether they are terrigenous or pelagic deposits. There is another scheme of classification which divides the ocean deposits into 3 main groups, namely littoral deposits, hemipelagic deposits and eupelagic deposits. We will be following the classification that is in the picture. Littoral deposits. They include those between high and low water marks. These include those of the continental shelf as well. They're estimated to cover around 62,500 square miles of the Earth's surface. They consist essentially of boulders, gravels and sands, and mud. Their nature is determined by the local features of the adjoining land. There's almost an infinite variety of littoral deposits, from huge boulders resulting in the denudation of cliffs to fine mud. The littoral zone is the habitat of a large number and variety of organisms, these naturally varying from the mangrove swamps and coral reefs of the tropics to the shellfish beds of the temperate regions. Generally speaking, the animal life is abundant, the chief groups represented being the mollusca, which is the cockles and mussels, crustacea or crabs, echinoids, that are sea urchins and starfish, and worms. Shallow water deposits. These are met from low water marks to the 100 fathom line. They cover about 10 million square miles of the Earth's surface. These deposits are also built up entirely of material derived from the land. Their constituent materials are smaller in size than those of the littoral deposits, but larger as a rule than deep sea deposits. Gravel, sands and coarse material predominate, but mud is by no means uncommon in the grooves and depressions, especially in enclosed basins. The mechanical effects of erosion are everywhere recognizable, naturally more marked in the shallower regions. These effects are due to waves and tides and currents. Deep sea deposits. These are found on the sea bottom beyond the 100 fathom line down to the greatest oceanic depths. They cover considerably more than one half of the Earth's surface and over 90% of the sea area. Gravels and sands are only met with accidentally in deep sea deposits, where depths over 100 fathoms are near the land. The chief deposits are muds, clays and oozes, the last of organic origin. In certain areas, the deposits are appreciably affected by the detritus of deposited floating ice. There is in general an absence of the phenomena of erosion. Since sunlight penetrates very little beyond 100 fathoms, it follows that plant remains are very scanty except near the limit. Animal life, however, for the most part is derived from the remains of pelagic forms. The temperature is very low, being below 40 degrees Fahrenheit over the greater part of the area. The conditions are uniform over very wide areas. The chemical action is characteristic and results in the formation in situ of, amongst other products, glauconite, phosphatic and manganese nodules and zeolites. The change from one kind of deposit to another is often very gradual, and there is evidence that one deposit may overlie another, though borings from the deep sea areas are as yet scanty and of only a few inches deep. Terrigenous deposits. The terrigenous deep sea deposits occupy 15.4% of the ocean floor. The terrigenous deposits of the littoral and shallow water zones are really of the same nature, and those forming the terrigenous deposits are the deep sea. These latter are, however, more uniform, homogeneous homogeneous and fine grained and widely distributed than the former. Of the heterogeneous deep sea deposits in the narrower sense, it is distinguished into three classes: the blue, the red, and the green ones. The two other classes included in this group are the volcanic mud and coral mud have, as their name indicates, certain special features which render their separate consideration advisable. Freshwater carries a much larger amount of sediment in suspension than salt water. Consequently, where a mixture of these waters takes place, there is rapid deposit of sediment on the bottom floor of the sea. This was first observed by W. H. Siddle in 1837 in the Mississippi Delta. Blue, red, and green mud. Blue mud is the most common deposit met with in deeper waters surrounding continental land and in all enclosed or partly enclosed seas, more or less cut off from the open ocean. When collected, it is either in blue or slate colored, with an upper red or brown layer in immediate contact with water. When wet, this mud is plastic and behaves like a true clay, but it really is more earthy than clay. The percentage of carbonate of lime varies from nil to 35. Blue mud is principally made up of land detritus, quartz being the characteristic mineral, which becomes less abundant with increasing depth until finally the blue mud passes gradually into one of these types of pelagic deposits. Blue mud areas afford an important example of the reduction of submarine clay after deposition. Red mud is a local variety of blue mud found in the Yellow Sea and off the coast of Brazil, where great rivers bring down sediment from the land. It is characteristic of tropical and subtropical seas into which drain rivers traversing laterite areas. The red color is due to large quantities of aqueous matters, the coloring being due to iron oxide. Red mud is especially characteristic of the South American shelf. It contains no glauconite. The organic matters present, though abundant, are not sufficient enough to reduce the peroxide of iron to a state of protoxide. The percentage of calcium carbonate ranges from 6 to 61, the average being 32. This carbonate of lime is derived from the shells of pelagic foraminifera. Silicous organisms such as diatoms and radiolaria are very rare. The mineral particles from the neighboring land constitute from 10 to 25% of the whole, the average being 21%. Green mud is a variety of blue mud distinguished by an abundance of grains of glauconite. It is found off high coast with few rivers to pour detritus into the sea. Example, the Cape of Good Hope, east coast of Australia, Japan, and the Atlantic coast of the United States. Glauconite is responsible for the withdrawal of potassium from solution in the sea. Glauconite sands are found off the east coast of the United States. Green sands and muds are not found in very deep water, only between 100 and 900 fathoms being the rule. Volcanic muds and sands occur off those coasts and oceanic islands where volcanic rocks prevail. The volcanic mineral particles are larger in shallower waters nearer the land, and the deposits here are called volcanic sands. Strictly speaking though, volcanic muds are a variety of blue mud. They are light brown, grey or black in color and have an earthy rather than a clay nature. In some regions, they pass gradually into blue and green muds, in others into coral muds and sands, or with increasing depth into globigerina, pteropod and diatombusis or red clay. The average percentage of carbonate of lime is 20.5. Volcanic muds and sands are found around all oceanic volcanic islands. They cover an area of around 750,000 square miles. Coral muds and sands. They are found in the vicinity of coral reefs and islands. They are derived from the debris of coral reefs. In shallow waters, sands are formed, but beyond the limits of wave action, a mud of triseriated particles of calcareous is met with. The predominant feature of the deposit is carbonate of lime, which averages 85%. Coral muds and sands cover an area of 2.7 square miles of the ocean bed, by far the greatest areas in the Pacific with 1.5 million square miles, then the Atlantic with 800,000, and lastly the Indian Ocean with 400,000. Pelagic deposits and fauna. They are predominantly composed of the shells of marine organisms. The red clay is, however, an exception to this statement. These shells are composed of either carbonate of calcium or silica. The physical conditions in these areas are remarkably uniform. The temperature is near the freezing point of fresh water and its range does not exceed 7 degrees Fahrenheit. Although most of the groups of marine organisms are present, there is no great wealth either in the number of individuals or species. Some animals have certainly been captured on the bottom, and these include worms, mollusks, holothurians, which are sea cucumbers, starfish, and corals. Here has summarized the available information in the case of fish. According to him, there are only 35 individuals belonging to 21 species and 6 families of fish, which have been really captured at these depths. The abyssal fish have a wide distribution, both horizontal and vertical. What I mean by this is they are found at places wide apart in the different oceans, or they occur on the continental slopes near the land as well as on the abyssal plains deep in the sea. It is certain that animal life is very poorly developed on the abyssal plain. The results show that fish and invertebrate life is very scanty at depths exceeding 2,000 fathoms. Pelagic deposits, the pteropod ooze. It is found in the shallower waters far from continental land on tropical and subtropical regions, and comes especially within the coral reef regions where warm water with small annual variation is found at the surface. Pteropod ooze was only found by the Challenger in the Atlantic, where it occurs near the Azores, the Antilles, west of the Canaries, and on the South Atlantic median ridge between Ascension and Tristan da Cunha. This ooze has also been found by other expeditions in the Indian and Pacific Oceans. The total area is small, not exceeding 0.4% of the ocean floor. The percentage of carbonate lime is, of course, high, averaging 80%. Globigerina ooze. It forms 29.2% of the ocean floor. And this ooze is most widely distributed on these average depths of 2000 fathoms. It is made up of largely of the dead shells of the surface foraminifera, the genus Globigerina predominating. The color of the ooze is white, yellowish or greyish, depending on the nature of the inorganic substances. The prevailing color is milky white or rose colored far from land and dirty white, blue or grey near land. The carbonate of lime varies from 30% in 2575 fathoms to 97% in 425 fathoms. The phosphatic concretions are rare in Globigerina ooze. The most common form is more or less rounded nodules of varying size. The manganese of these nodules is chiefly derived from the decomposition of the more basic volcanic rocks. Globigerina ooze has a very wide distribution on the ocean floor. Its total area is over 49.5 million square miles, coming second only to the red clay. Its maximum development is in the Atlantic, 22.5 million square miles, occupying by far the larger portion of the seafloor of this ocean from the Arctic Circle to 60 degrees southern latitude. In the Indian Ocean, it occupies about 12.25 million square miles. In the Pacific, the area is over 14.75 million square miles. Diatom ooze is a siliceous sediment composed mainly of the shells of plants, diatoms. It is found in high latitudes in both hemispheres and originates in the phytoplankton. The name was introduced by Murray in his Challenger report and applied to a deposit which, when wet, has a yellowish straw or cream color when dry. When dry, nearly pure white, resembling flour. The surface layers are thin and watery, the deeper layers laminate. Near land, it takes on a bluish tint. The calcium carbonate percentage is low, ranging from 3 to 30%. Diatom ooze forms a white zone around the south polar regions, lying for the most part between the Antarctic Circle and 40 degrees southern latitude, where it covers over 10.75 million square miles. There's also a griddle in the North Pacific extending to 40,000 square miles. Last two sediments, the red clay and the radiolarian ooze. They are sometimes called the abyssal deposits since they occupy the greatest depths of the ocean floor. The radiolarian ooze may in fact be regarded as a local variety of the red clay. It differs in containing a large number of siliceous remains for the shells of radiolaria. Red clay is characteristic of the greatest depths of the ocean floor. It is the most widely distributed of the deep sea deposits. The color of deposits varies greatly, but red is the prevailing tint. In the North Atlantic, brick red, and in the South Pacific and Indian Oceans, dark chocolate predominates. I would just like to say one small note before ending this slideshow. The book which I took most of the resources from is called A Textbook of Oceanography by James Travis Jenkins. It is a really good book, but it is quite outdated, over 50 years old. So some of my information may not be that correct. Thank you.